Good morning, students. This is Atulya Thomas, your chemistry teacher. So, in the last class, we had started with the first chapter of chemistry, that is matter in our surroundings, right? You remember? Yes. So, we started with the physical properties of matter, right? We started with that two main properties we had learned in the previous class, that is, matter is made up of particles and particles of matter are small in size, right? And we understood it through experiments and with the help of two activities. So now all of you know that particles of matter are small in size, as well as we know that matter is made up of particles called as atoms, right? So today we would be covering the other three properties, other three characteristics. Okay, so the first one is nothing but particles of matter have space between them. What is it? Particles of matter have space between them. So it can be this property or characteristics can be proved by the activity which we have already done. This activity have already explained you for the property that matter is made up of particles. Okay, the same activity will also prove that particles of matter have space between them. Okay, if you take a beaker, okay, the activity was like, if you take a beaker and add water, you will mark the level of water, and when you add some sugar, you will see there will be rise in the level of water, right? The level of water will be increased. Then when you start stirring the solution, when you start stirring or mixing the sugar into the water, you will observe that, what will you observe? That the level of the water comes back to the mark, right? The level of water which had increased, now the level of water after mixing the sugar into the solution, the level of the water comes back to the same mark, right? So what will happen? So this experiment shows us that, or proves us that matter is made up of particles, that we know, and it also shows us that the particles of matter have space between them. How do we understand that they have space? See, first you have added sugar. What did you do? You had added sugar. So the sugar remains separated and water remains separated. That is why the level of water got increased. Then you started mixing. You started mixing the sugar into the water. Then what happened? The sugar molecule started getting into the spaces between the water. Water molecules have space between them, and the sugar molecules उसके बीच में जाके बैठने लग गए. शुगर मॉलिक्यूल्स क्या हुआ? शुगर मॉलिक्यूल्स ये पानी के मॉलिक्यूल्स के बीच में जाके बैठने लग गए. मिक्स होने का मतलब क्या है? शुगर मॉलिक्यूल्स वाटर मॉलिक्यूल्स के बीच में होने लग गए. ओके, दैट इज द वाटर मॉलिक्यूल्स एंड शुगर मॉलिक्यूल्स गॉट मिक्स्ड अप, and sugar molecules got into the spaces between the water molecules. So this shows us that the particles of matter have space between them. Okay, and they are even small in size, and they have space between them. Okay, like when you make tea, or when you make coffee, or nimbu pani, anything like that, the particles of one type of matter get into the spaces of the particles of other type. That is, when you are making tea, what are you doing? You are adding milk, you are adding water, you are adding tea powder, right? So what is happening? The milk and water, does it remain separated when you are making tea? No, it gets mixed up. What is it happening? Water and the milk, both of them get into the spaces of each other, right? Both of them get mixed properly, means both of them get into the spaces of each other. Similarly, when you are making lemonade, you are adding lemon juice into water. So what is happening? Does lemon juice and water remain different separately? No. When you are mixing, everything gets mixed up, right? So and sugar also, when you are adding lemon juice, water and sugar, three of them gets mixed up properly, right? Because lemon juice, sugar and water get into the spaces of each other. That is, they are getting mixed very well. So this proves us that matter have space between them. That is, particles of matter have space between them. Okay, so have you understood this first characteristics? First, that is, we had learnt already two. This is the third characteristics, that particles of matter have space between them. Okay, now this is another activity which I have explained you. Same activity which I have explained you of sugar and salt, that is when you're dissolving, the level of water is rising, and when you start dissolving it, when you put sugar, level of water starts increases. Then when you start dissolving, the level of water comes back to the original position. That this is the same activity which shows that particles of matter have space between them. This activity is given in your textbook on the first page, okay, which I have sent you a PDF. Please open the first page. You can see this activity is given, which shows that matter is made up of particles. Also, it shows that particles of matter have space between them. Okay. So now let us move on to the next property, that is particles of matter are continuously moving. What does this mean? That is, it means that particles of matter are continuously moving, right? So let us prove this can be understood properly with the help of an experiment. Okay, now what do you have to do? You can try this at home also. Take a beaker, okay, fill it with water. Take a beaker, fill it with water. Okay, now add some pulses, like you can even add some dal or some pulses you add into the beaker, and leave the beaker undisturbed for some time. Okay, what did I tell you? I told you to take a beaker, add water, and add some pulses, can be dal or any pulses, okay, and leave the beaker undisturbed for some time. What will you see after some time? You can observe that the seeds start moving in a zigzag motion. In this also you see the seeds are all moving in a zigzag motion. In a beaker containing water, the seeds will move like this in a zigzag motion. It will move all around the beaker, right? This motion is nothing but called as, so this motion is where the seeds keep moving in a zigzag motion. This motion is called as Brownian motion. What is it called? It is called as Brownian motion. Okay, if somebody asks you what is Brownian motion, the zigzag movement or motion of the particles is called as Brownian motion. Okay, now this experiment which I told you now, that is, if when you add seeds, you will see the seeds moving in zigzag motion. This activity proves us that particles of matter are continuously moving. Okay, you have put seeds into it, or you have put pulses into it, and you have kept it undisturbed, and after some time when you will be coming and seeing it, you will see all the seeds or the pulses are moving continuously into the solution or in the water. So this shows us that particles of matter are continuously moving, okay, and they possess some amount of energy. That may be kinetic energy. Kinetic energy is nothing but they possess some amount of energy, okay, which rises on the rise of temperature. That is, when you increase the temperature, the particles start moving faster, and when you decrease the temperature, the particles don't move much, but they when they have energy, that is, they possess kinetic energy. And when you increase the temperature, you can see the particles will start moving faster. Okay, when you increase the temperature, keep that beaker on the stove, and when you heat it, you will see that particles start moving even more faster. And when you decrease the temperature, okay, you will see the particles movement also becomes slow. Okay, so this is also another example where we can understand that particles of matter are continuously moving. In this, what is happening? They have taken a beaker, okay, and they are adding ink into it. All of you know ink, right? Take a beaker, add water, and add few drops of ink into it. You will see the ink will start spreading into the solution like this. Why is it spreading into the solution? Because the particles of matter are moving. That is why it is getting spread into the solution. No, if the ink could not move, okay, if the particles of matter could not move, what will happen? Where you will add ink, there only ink will be present. Rest all the solution will be clear, right? But particles of matter are continuously moving. That is why the ink is getting spreaded. Can you see? First you have added ink. Ink is getting spreaded into the solution. The entire solution is going to become blue. And finally the entire solution becomes blue. because particles of matter are continuously moving. Right here, if the particles of matter were not moving, if you add ink here, only this area would have been blue, rest all would have been clear, right? And this processes would not have taken place also. But particles of matter are moving, so finally you will see the entire clear solution turns blue in color because the particles are continuously moving. Now if you carry out this experiment, same experiment, where you are adding 2 to 3 drops of ink, okay, when you are carrying out this experiment in hot water, okay, what will happen? You will find that the water turns blue or purple. In this below activity I have given you purple color solution. You can even connect it to the this previous activity also. It's the same, just the color of the solution is different. So if you carry out this experiment in hot water means temperature is more, okay, in higher temperature you are carrying out this activity in hot water. What you will see? We will see that the water turns blue or the water is turning purple at a very fast rate. Okay, when you heat the temperature, particles will move faster. We have understood. That is why when you are using hot water, we will see that the water is turning purple or blue in color very faster. Okay, now if I take this beaker, I have added ink and I have put it in I have put this ink into hot water. Then the process will take place very fast. The entire solution will become purple within few seconds. Okay, so now what did I say? I will say if I have taken hot water, the entire solution will become purple within few seconds. Why does this happen? So this is because on heating, when you are heating, the particles of water that contains this potassium permanganate, this purple color is because of potassium permanganate, okay, which we have already learnt, the activity which we have learnt, right, in the previous class of taking 10 ml and transferring into the next beaker. The same potassium permanganate activity is only given here, okay, but activity is not the same. The compound potassium permanganate is the same, okay. So what is happening here? When you are heating, what is happening? I'm going to put 1 drop of potassium permanganate into the water. Now I am going to heat. When I am heating the solution, what will happen? The potassium permanganate will gain kinetic energy, right? It will gain some amount of energy and will start moving faster, right? In hot, I am heating the process. I have added potassium permanganate, okay. Now I am going to heat the solution. On heating, I will see potassium permanganate will gain kinetic energy. After it gains kinetic energy, I will see that the particles of matter will start moving faster. See, in the first beaker just few drops are there, okay, I am just adding 2-3 drops, and in the second beaker you can see just few drops of ink is present, right? Now finally in the third beaker, can you see the entire ink has been spread into the solution, okay, and finally what do you get? You get a beaker with full solution which is purple in color, because when you heated, the potassium permanganate gained kinetic energy and they started moving faster and they got mixed into each other very quickly. That is why this reaction has taken place. So it shows us that particles of matter are continuously moving and it depends upon temperature, right? So since temperature is more here, that is we have heated it and the temperature is more, it gained kinetic energy and started moving faster and the entire solution became purple very quickly, okay. Now if you can even see the same activity in a dark room, right? That is when you take agarbatti or when you go into a dark room, okay, without switching on the light, when you put on a torch, okay, when you put on a torch and put the beam of the light into the dark room, you can see certain particles and all moving in the dark room, right? You can see it very clearly. Similarly, if you take this incense stick, agarbatti is called as incense stick, okay, if you take this incense stick and you keep it in a dark room, can you see the zigzag motion of the particles? See, the vapors or the particles are moving in a zigzag motion. It is not going straight, it is not going in the left side, or it is not going in the right side. All of them are going in a zigzag motion. Zigzag means what? कोई पर्टिकुलर वो नहीं है, मोशन नहीं है कि सीधा जाएगा टेढ़ा जाएगा. नो, इट गोज in its own way. Zigzag, teda meda, it goes. Zigzag means teda meda. Okay, so now you can see the particles of this instant stick is going in a zigzag motion. Okay, this is also another example you can see in a dark room. Okay, now let us move on to the next property, that is particles of matter attract each other. What all we studied now? Today we have studied particles of matter have space between them. Then we understood particles of matter are continuously moving. Okay, now next last property we are going to study is particles of matter have force of attraction between them, or particles of matter attract each other. Okay, this can also be understood by using by an activity, that is when take any solid. Okay, if you take a table, consider a table, take an example of a table. Okay, can you move your hand inside the table? क्या तुम अपना हाथ टेबल के अंदर डाल सकते हो? No, right? You will not be able to put your hand inside the table. और टेबल के अंदर से हाथ हिलाना तो बहुत दूर की बात है, right? You will never be able to put your hand inside the table. Why? But if you take a bucket of water, are you able to move your hand inside the water? Yes, I am able to move my hand inside the bucket of water. Now if you keep your hand in air and you start waving or you start moving your hand, does your hand move freely in the air? Yes, my hands can move freely in the air, but it cannot be moved in the solids, or it cannot move properly in the solids, but comparatively it can move easily in liquids and very much easily in gases. Why does it happen? So this condition is, these conditions are not same in case of solids. You take any solid, if you take a polythene cover, if you take a notebook or textbook, can you move your hand in between the textbook? Can you put your hand through the pages of the textbook? No. Why? Because solids have greater force of attraction. Solids में force of attraction बहुत ज़्यादा है. Okay, solids have greater force of attraction between them. That is why the particles are sticking to each other. They are united to each other. Okay, so separating those particles is very difficult. That is why you are not able to move your hands through solids. But comparatively liquids may force of attraction is little bit lesser. That is why you are able to put your hand in the bucket of water and move your hand through the water. Okay, and in gases, the force of attraction between the particles or molecules is very less. That is why without any problem or without any obstruction, you are able to move your hand in air. You can wave, anything you can do in air, right? Because the force of attraction is very low, very less. Okay, but in solids, I have explained here, in solids it is impossible to move it or do anything with solids or move your hand inside solids, because they have greater force of attraction between them. Okay, you need to remember this. They have greater force of attraction between them that keep these particles united. Okay, particles एक दूसरे से चिपका हुआ है. They are united to each other, and hence they cannot be even separated. Okay, so they have greater force of attraction and they are united, so they cannot be even separated. Okay, this is nothing but, so they cannot be even separated. So this shows that particles of matter have force of attraction between each other, attract each other. Okay, see, you are able to move your hands in the water and you are even able to move your hands in air, because force of attraction in liquid is less, force of attraction in air is more. So that is why you are able to move your hands in water, in air freely, but not in solids, because they have more greater force of attraction. Okay, now this experiment proves us that particles of matter have force of attraction between them. Okay, so solids, you can see the particles of matter are so closely packed. See, so in solids, इतना चिपक चिपक के है, it's united to each other, so it is very very difficult to separate the solids. See, it's continuously packed without proper spaces, so that is why they have greater force of attraction. But in case of liquids, you see the particles are little bit far away, right? There are some spaces between the particles. So what does it show? It shows that particles of matter have force of attraction but less than solids. Okay, liquids have force of attraction between the particles but it is less than solids. In gaseous, you see, in gases, what is happening? The particles of matter are very very far from each other in gases, right? So the particles, you can see, they are freely moving. That is why you are freely able to move your hands in air, in gas, because the particles of matter, the force of attraction is very very less compared to solids and less compared to liquids. Okay, if you compare solids and gas, particles of matter, force of attraction is very very less in gas. If you compare to liquids, gases, the force of attraction between particles is less. Okay, I hope you have understood the last characteristics of matter, that is particles of matter have force between them. Okay, this is another example which I wanted to explain you, that if you take an iron ball and if you start beating it with an hammer, will you be able to break it? No, you will not be able to break it, because the particles of iron ball have greater force of attraction. Okay, they are much more united, they are much more closer, and they have greater force of attraction. But if you try to break a chalk piece, can you break it? Yes, you can easily break the chalk piece with hand. तो hammer तो दूर की बात है, with hammer तो you can make it into powder, right? So you in iron ball you are not able to even change the shape of the ball also, because force of attraction in iron ball is greater. But in chalk piece, the force of attraction is very very less. That is why it can be easily be broken and into powder also, right? Or into pieces, or it can be even made into powder form also, because the force of attraction in the chalk piece is less. Now let's move on to the today's new topic, that is states of matter. Okay, we must understand, or we must know that there are three states of matter, that is solid, liquid and gas. What are the three states of matter? Matter around us exists in three states, that is solids, liquids and gases. So let us move on to the next slide. Okay, here we can see that the different states of matter. How did these different states of matter arise? The different states of matter arose or arised because of the characteristics of these particles. What are the characteristics? First characteristics we have already learned one characteristic, that in solids the particles are very close to each other and they have greater force of attraction. But in liquids the particles are little bit far from each other, in liquids, and the force of attraction is less. In gases, the particles are very very far from each other and the force of attraction is very very less, right? So already we have understood the characteristics of both of the three, solid, liquid and gases, is different. That is why these states of matter have arisen, because of this variation in the characteristics, because of the variation in force of attraction, in variation in compressibility. Okay, now in the next class onwards we would be learning the different properties of solids, liquids and gas. What are the different properties of solids, how does it be different from liquids, and what are the different properties of liquids, how is it different from gases, and what are the different properties of gases. All these three we would be studying in our next class. Okay, I hope you have understood this video. If you have not understood, please message me personally. Feel free to ask me your doubts. I am always ready to solve it. Okay, thank you.